Hello everybody, this is Unit 1, Day 5. We're talking about angle relationships. Okay, so the last section we were talking about angle measures. We're going to kind of build on some of those concepts and try to keep this thing short and sweet. All right, so let's rock and roll. So angle relationships. Some pairs of angles are special because of how they're positioned in relationship to each other. Three of these angle pairs are described below. So as you can see, we have adjacent angles, linear pairs, and vertical angles. So adjacent angles look like this section right here. Okay, so they're just next to each other. There are two angles that lie in the same plane. They have a common vertex, okay, and a common side, but no common interior points. Okay, so if you look at your non-examples, okay, you can see that these aren't even really touching, and this angle actually incorporates or has that one inside it. So these are non-examples over to the right here. Okay? Linear pairs, right? A linear pair is a pair of adjacent angles. Okay, so we got our adjacent angles here, right, with non-common sides that are opposite rays. Okay, so oof, what does that mean? Well, that means that they do not share this side in common here. Okay, the one I just highlighted. They do not share that side in common. But what do we know? We know that that is a straight angle, right? And that creates a nice straight line. And that will play into part later down in some further definitions, okay? So you need a nice straight line. And the reason why the non-example doesn't work, okay, these lines are not opposite rays, okay? They don't go straight. So therefore, this is not an example of a linear pair, okay? And lastly, we're going to talk about vertical angles in this bunch. Not lastly for the lesson. Vertical angles are two non-adjacent angles formed by two intersecting lines, okay? So what do I mean by non-adjacent? Okay, well, 1 and 4, are adjacent. 1 and 3 are adjacent. 3 to 2 are adjacent. Okay, so I don't want to use ones that are right next door. Okay, I want to use the ones that go right above it. Okay, so your vertical angles are 1 and 2 and 3 and 4. Okay, they're kind of opposite each other. They're not next to each other, right? They are kind of opposite the the crosshairs there. Okay, so vertical angles, in this particular case, 1 and 2, and 3 and 4. And again, another non-example, as you can see, we have a nice straight line here, but then this line comes up, and then this starts to go to the side. Okay, so therefore, we know that this is not an example of vertical angles. Okay, so let's take a look at this piece down here. Now, I got to add one more thing to this, otherwise my example won't work. We'll call it like that. There we go. Okay, so let's put some points on there. Nice point there. Point there. Point there. Forgot one thing. Draw my arrow. Okay, let's label some of these points here. All right, so I'm going to go H for Haley, L for Logan, O for O'Keefe, J for JC, C for Kaya, and who we got left here? Who do we have left? 1, 2, 3, 4. Haley, Lauren, JC, Logan, Julie. We'll give you a B, and then we'll just make the center one A. Okay? So, all right, so the task is asking us to name an angle pair that satisfies each condition. Okay, so two acute vertical angles. That would have to be these two guys right here, right? Because we got a nice straight line, okay, for both cases, right? And they both appear to be smaller than 90 degrees. So the angles there are going to be, erased my, there we go. Angle BAC and angle LAO. Okay? So those are our two acute vertical angles. Now let's do the two obtuse angles. Adjacent angles, sorry. Two obtuse adjacent angles. That's a tongue twister. All right, so what are we looking for? Well, I see one obtuse angle here. And I see another obtuse angle here. Okay, and so, and as you can see, they're not sharing. They're sharing, you know, their vertex. Okay, but they're only sharing one side. Okay, so, and they definitely appear to be larger than 90 degrees. So we have angle CAH and angle JAH. And those are our two obtuse adjacent angles. Okay, let's move on to the next one. Some pairs of angles are special because of the relationship between their angle measures. Okay, so now we're going to start talking about some of the relationships of these terms, or those definitions I brought up just a second ago. So vertical angles are congruent. Okay, so going back to that example, we had 1, 2, 3, and 4. Okay, what we know is that, I mean, this is something that's just been proven, and we can just assume that. Okay, so we're allowed to assume this. Okay, so anytime we see two lines that intersect, we can assume that this angle is equal to this angle, and this angle will be equal to this angle. Okay, so we can assume that because of this definition. So what this is saying here is that the measure of angle 1 is congruent. Oh, I'm sorry, not the measure. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Okay, and what that means is when you have two things that are congruent. Okay, so you can take this a step further. When I say angle 1 is congruent to angle 2, what I'm saying is the measure of angle 1 is equal to the measure of angle 2. And that's what I mean by, excuse me, vertical angles. Okay. So, let's look at complementary angles. All right, complementary angles are two angles with measures that have a sum of 90 degrees. Okay? So, if you look at this first example, you'll see that we have a right angle. Okay, the reader gave it to us. So we know that that angle's a right angle, but then also, okay, it's been separated by this ray right here. So we know that the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Okay? I'm just adding those angle measures together. Now over here, on the other hand, sometimes the angles might not be right next to each other. Okay, they might just be floating around in Neverland, right? So what we can say here, though, is that when we have an angle, well, in this case we have an angle that measures 65, we have another angle that measures 25. When I add those two together, the measure of angle A plus the measure of angle B, I get 90. So in this particular example, we could say A is complementary to angle B, okay, because they're not really attached to each other, but we do know if we add their two angle measures together, their sum is 90. Okay, same thing goes for supplementary angles. All right, supplementary angles are two angles with measures that have a sum of 180 degrees. Okay, so again, if you look at this example up here, all right, what do we got? Well, the first thing I notice is we have a straight angle, which means this is a nice straight line across, okay, which also means that it is 180 degrees. And then we got this other ray kind of sticking out the top, all right? And so if I added the measure of angle 3 plus the measure of angle 4, I would get 180 degrees, okay? And same thing over here with P and Q. The measure of angle P plus the measure of angle Q is equal to 180 degrees, okay? So sometimes, again, the angles might not be sitting right next to each other like we have in this example up here, okay, which we'll get into this, which we've already discussed, right? This is a linear pair, right? So this linear pair, it looks a little more obvious that it would be 180, right? And sometimes you just have to add the two angle measures together to see whether or not they're supplementary or complementary, okay? So supplementary means that the two measures add up to 180. Complementary means the two angle measures add up to 90. Now the last piece, okay? The angles in a linear pair are supplementary. Okay, what does that mean? Well, if you look at this example up here, we have a nice flat line, right? Nice straight line. Okay, and so if I were to add this piece and this piece, I would get 180 degrees. So you just got to remember that angles in a linear pair are always supplementary. Okay? And also remember that angle measures are real numbers, so the operations for real numbers in algebra can be used with angle measures. Okay? And so that's just a fancy way of saying that there's going to be some algebra involved. Okay? Let's take a look at these last two problems, and I think that is it. Okay? So, last three problems. I apologize. So, it says, now this is where they start mixing a little bit of algebra with these terms here, okay, or these concepts. So it says, the first thing it says, find the measure of two supplementary angles if the difference in the measures of the two angles is 18. Okay, all right. So let's just kind of give ourselves a little diagram. Sometimes it's nice to draw a nice little picture. Okay, so find the measure of two supplementary angles if the difference in their measures of the two angles is 18. Okay, so what that is saying is one's going to be 18 degrees larger than the other. Okay, that's fine. Rock and roll. All right, so now let's think about this here. Okay, I know that this piece plus this piece equals 180. So I'm going to set that up. So I'm going to say x plus, and I'm going to actually, let me label these so we know which one we're talking about. So I'm going to label this one side 1, this side 2. Okay, so angle 1 is equal to x plus, well, actually, let me write out the formula here, right? So we're going to go the measure of angle 1 plus the measure of angle 2 is equal to 180. Okay? Now, let's do some substitution. So I'm going to substitute x plus 18 for 1 plus x for 2 is equal to 180. I'm going to add 2x. I'm going to subtract 18. So 180 minus 18. You get 2x is equal to 162. Divide by 2. And you get a grand total of x is equal to 81. All right. Now, am I done here yet, though? Hopefully you're saying no. Okay, so I need to take this value. So it wants us to find the exact measures, right? So one of the measures is going to be 81. Okay. How do I find the other measure? Well, I plug it right back into this expression up here. So 81 plus 18 is 99. Let's add those up. 81 plus 99 is 180 all day. So therefore, there is our angle measures, okay, with a difference of 18. Okay. Last two examples. So find all the missing variables. So here we go. We got some examples of some vertical angles. Okay, I'll be honest with you. I kind of like these problems because, I don't know, it just kind of makes you think a little bit. And realistically, like you're still doing just multi-step problems at the end. You just got to make sure you're setting it up correctly. Okay, so that's the trickiest part about these is just making sure your setup is okay. So let's set this up right. So what do we know about these two angles? Well, these are vertical angles, so we know that the two measures are the same, which means I can go like this. 120 is equal to 2x minus 10. Okay, so I'm just setting those two values equal to each other because I know, being that they're vertical angles, their measures are the same. And now I'm going to add 10. So I get 120. 130 is equal to 2x. Divide that by 2. You get x is equal to 65. All right, now let's make sure that works. So what's 2 times 65? Whoops, 2 times 65 plus, or minus 10 is 120. Okay, so now here's the million-dollar question here, though. Okay, so let me rewrite this. If this is 120 and this is 120, what are these angle measures equal to? And I'll give you a second to think about that before I jump into the next example. Okay. So I'm going to run out of space here, so I'm going to try to draw a little arrow. I'm going to do it in green. Okay, so hopefully you're not getting lost in the sauce. All right, so here we got another example of vertical angles. Okay, so because these two are opposite each other, just like we did over to the left, I'm going to set these two things equal to each other. And I'm going to solve for x. So I'm going to subtract 2x. I get 25 is equal to x minus 10 plus 10. And I get x is equal to 35. Plug that back in. So I'm going to plug it into, that doesn't matter. So I'm going to plug it back into the 3x minus 10. So 3 times 35 minus 10 is equal to, so 3 times 35 minus 10 is 95. Okay, so these two angle measures, I'm running out of space again. Okay, let me zoom in here. These two angle measures right here are 95 degrees. So now, how can I find out what y is? All right, what we're going to have to do is you have to think about, okay, let me draw a different line here. I want everybody to just focus on the pink line here. And what kind of relationship does this guy over here and the y have? Okay. Well, if it hasn't hit you yet, this is an example of a linear pair. And what do we know about linear pairs? Linear pairs add up to 180 degrees. So in order to find out what y is, okay, I would have to take 180 degrees, subtract 95, and voila, you're getting 85. So 85 is the measure of y, which means this is 85, which means this is 95. And let's add all those up. So if I went 95 plus 95 plus 85 plus 85, what do you guys think it was going to add up to? It's going to add up to 360. Okay? So just remember, right, in order to find those other two missing sides, okay, we could have done like this. We said, okay, if they all add up to 360, you know, I divide 180, or I go, I'm sorry, 360 minus 95 times 2, okay, get 170, divide 170 by 2, you get 85, okay? But you also want to just look at the fact that in pink there, we have a linear pair, and all linear pairs are supplementary, and so therefore, that's how you want to think about that, okay? So vertical angles are congruent, linear pairs add up to 180 degrees, okay? Now, this isn't in your homework, so I kind of took that part out, okay? And so for homework, I want you to try all the problems you got left behind here, okay? So, good luck, you guys. God bless.